Hi there guys, today we're going to learn about sequences and series. So, to start off with, you need to recap what we know from our earlier studies at ch6. So a sequence, you should know, is a series of numbers following a set rule. So why don't you, let's get our brains working, pause the video now and see if you can work out the rules for these three. Okay, so hopefully you've had a go. This first one, if you look at one number to the next, it's going down in threes. The next number is slightly harder, but it's doubling. And the next one, even trickier, it's doubling and then adding 1. So as you keep going through, you double your previous term and you add 1. Okay, pretty simple stuff. So what we need to do is introduce this new terminology. So if we see this UN, that's how we're going to now write the nth term. So instead of writing the words nth term, it's much easier to write UN. So, for example here, if the nth term of some numbers was 3n plus 1, the 3 times table but 1 more, we just write UN equals, so the nth term equals. And it definitely makes it easier to find any term in a sequence. For example, if we want to find the second term, we are simply swapping this number here, this letter n, for the number 2. So this is the second term, and we substitute in here and here. Pretty simple. So, like before, we can use the nth term to test to see if a term exists in the sequence. So, if we have an nth term 3n plus 1, and we want to know is 94 in it. So, if we put them equal to each other, what we are saying is 94 equal to this nth term, and if it is, therefore 94 is inside that sequence. So you just solve it like a normal equation, subtract 1 to both sides, divide by 3, and we know that 94 is the 31st term along in the sequence 3n plus 1. Again, this isn't anything new to you. However, this looks far more difficult, and you didn't come across anything like this in a GCSE. So there are exercises in your books that practice just this skill here, but this is when it starts to get more interesting. So here we've got a sequence, we've got an nth term, but there's no numbers in it, which automatically starts to freak us out a little bit. But please do not panic, because we need to use this information. I've nicely made it highlighted so you can see this stuff easily, but in your books you're not going to have this luxury. So A and B are both constants. Please don't be put off by this word. It just means they're a number. A constant is a number, and that's what we've got to find. So if we think U3 is 5, so we know the third term along is 5. We know the 8th term along is 20. Basically, using this formula here at the top, the UN, well, this is the 5th term, 5 is when n is 3. So all we've done is put this 3 in for n. So we have 3a's plus a b. So that's going to be 3a plus b. So we know that the third term is 5. And we can do exactly the same with the 8th. So if we put this a into this part here, we're going to have 20 equals 8a's plus b. Now you should notice something straight away. You've got two equations. When you have two equations, our only option really is to solve them simultaneously. So let's do that. Please remember, it doesn't matter which one you label 1 and 2. You have two options here. Are the coefficients the same? Yes. We've both got b's in 1 and 2. So what we can do, we can go ahead and eliminate. Oh, so that's shocking, but you understand. So you eliminate these b's. We're going to do that by subtracting. So I'm going to, let's just pop this up here, and I'll tell you what, let's just get rid of all that ink because it's messy. There we go. We're going to subtract them. So 8a take away 3a is 5a. The b's will be eliminated, and we get 5a as 15, and then of course a is equal to 3. So we've done a, we've also got to find b. So let's sub it in. I've chosen number 2 purely because the numbers are a little bit easier. So let's take a and pop it into equation 2. So we're going to have 5 equals 9, because 3 times 3 is 9, plus b, and therefore b is 4. Sorry, b is minus 4. At this stage, it's really important, I haven't done it there, it's really important to check your work, check that you've done it correctly. Okay, and we're going to show you some really tough ones now. So here it says prove, and this is the book that we're using at the top here, exercise 6b, question 3. If you're using the same C1 books, then great. But prove that the 2n plus 1th term of the sequence un is n squared minus 1 is a multiple of 4. That is horrendous when you first see it. But let's try and break it down. So here's this sequence n squared minus 1, so it's just squared numbers, one less. And if you think of 2n plus 1th term, so there's u1, there's u2, u3, etc. But 2n plus 1 up here, 2n plus 1, that means your 2 times table but one more. So that's 3, the 5 and the 7. So these ones I've lit up in green here, it's prove that these numbers are in the 4 times table, which you can clearly see they are. Okay, so if it said find the 4th term, just like before, you'd pop in a 4 for n. So instead of writing like a 4, we're actually going to put this whole thing in here. So I don't know how I just did that. So here we go. So n is 2n plus 1. So we're just going to pop it in. Like I just said, instead of writing this n here, we're going to write the 2n plus 1. Naturally, you've seen this, you can expand these brackets. Make sure you expand correctly. If you need to, you might do a little step in here, like draw this bracket out twice, because squared means times by itself. Tidy that up, you'll see that ones cancel, and then we have this. So we have the nth term can be written as 4n squared plus 4n. Now if it's a multiple of 4, it means 4 is a factor. It means can we take a 4 outside the bracket? And of course we can. And by writing this bit in orange here, the 4 outside means we can times it by 4 to get this, and therefore it's a multiple of 4. If it was saying it's a multiple of 3, try and take a 3 outside, and so on. Okay, one last horrible question for you to look at. And it's all about proving. When we start using this word, people naturally get more confused. So prove that the terms of this sequence are all positive. Okay, let me just underline this bit. Okay, they're all positive. I'll come back to that bit because first of all, when you see this, my first thought is, well, this is a quadratic expression. Can't do much with that. So what I'm going to do is try and write it in a different form. So how else can I write this? So normally we factorize. So are the factors of 27 that I can easily make 10 from? 9 and 3? No. 27 and 1? No. So not easily. I'm going to have to use the quadratic formula or another means to do that. And write our answer to one decimal place. So that's no good. So how else can we write this? So we've got normal factorising, we've got completing the square. And that is it, completing the square. If you need to just double check that, please do. Okay, so now if I come back to these words that are all positive, this is done. Because what happens when you square a number? Any number, whether it's positive or negative, when you square it, it'll be positive. For example, minus 3 squared, well, that's 9. 3 squared is also 9. So it doesn't matter whether the outcome of this bracket is positive or negative. When we square it, it's going to be positive, especially when we add 2 to it. So all numbers squared will give a positive outcome, so un will always be positive. Now, for what value of n is, well, un the smallest? So when is this value here the smallest it can possibly be? So let's think about what we can do in this bracket. So when we square it, gives us the smallest number possible. So I'm sure you've seen that if that's 5, so the answer here is 5. Because when it's 5 take away 5 is 0, 0 squared is 0, plus 2 is 2. And therefore un would equal 2. Okay, so that's the end of the video. Go and get practicing those, but those last 3 there, they're the toughest it's normally going to get. So I hope it helps.